Okay, problem number 14. An airplane's velocity is 625 miles per hour, headed directly southeast. Let's draw that as a vector. If it's going directly southeast, that tells me it is going south 45 east. If we're thinking about it in a bearing, directly southeast is putting us going down right like that, with that 45-degree angle right there. What else do I know? I know a strong wind begins to blow at 85 miles per hour from the north. If it's blowing from the north, it is blowing to the south. So I need to add the wind vector to the plane's vector to get this purple vector going straight south, right off the tip of the pink vector. And I know that has a magnitude of 85. I know that pink one had a magnitude of 625. And now I want to figure out some information about this resultant. Right there, green line going straight down. The magnitude of that green line will represent the plane's speed with respect to the ground, and then I can find the true bearing after that. So I now have a triangle here, which I can figure some information out about. First off, recognize that if we go straight up from that purple line, we know that's a north-south line, which means I have alternate interior angles. I know that pink angle right there is 45, which means that angle right there is also 45, which then makes this angle 135. Now, I hope you recognize that we have a law of cosines problem. We got 135, we've got 625, and we've got 85 right there. So we can find that value C by taking C equals the square root of 85 squared plus 625 squared minus 2 times 85 times 625 times the cosine of 135. Crunch it, and you should get like 687 something. You should get roughly 687.735. So that would be the plane speed with respect to the ground, 687.735. But we also need to know what is the true bearing, aka the bearing of the resultant of the plane. And so we need to figure out what this purple angle right there is, because that will tell us the bearing, how many degrees off of south is the plane actually flying. And to figure that out, we first need to figure out that theta right there, because we know that whole pink angle is 45. So if we can subtract theta from 45, we'll get that purple angle. So let's set up a law of sines proportion. Sine of that theta divided by 85 equals the sine of 135 divided by the value we found for C right there. I'm just going to write it as C. I don't feel like writing it all out. So that means that the sine inverse of 85 times the sine of 135, close your parenthesis, divided by second answer will give us our value for theta. And so if you do that, you should find that theta equals roughly 5.014. But no, that's not our answer. We need to figure out, again, this angle right here, because that's going to tell us our bearing. Well, how do we get that? We need to take 45 minus that theta we found. So 45 minus 5.014. 45 minus second answer will give us 39.986. And that would mean, as a bearing, that is south 39.986 east. And that, my friends, is this problem.